This is Ben. He's published a scientific paper on spaghetti. This is Neb. He's wondering why he should believe a scientist like Ben. The answer to this question, simply put, is you shouldn't. Ultimately, you should believe in the scientific method, which is the process that the scientific community uses to find out how the world works. A scientist is merely a vessel to carry out this process. So let's see if Ben can convince Neb that the scientific method is worth following, by explaining why spaghetti has to break into more than 2 pieces. Problem formulation is the process of converting real world into a situation we can understand. Understand means that given sufficient information, we can always predict what's going to happen next. Determining a good question requires creativity and dedication, and is often very difficult to do. Now that we have a problem, we need the answer. So we take a guess at what's happening, and this is the hypothesis. You can hypothesize anything you like. Maybe an alien force put away the extra pieces from the spaghetti. But we need to be grounded in reality. Ambition is one thing, absurdity is another. Thus, the humble and reasonable Ben thinks of another hypothesis. Perhaps the vibrations travel through the spaghetti and affect the weaker points. With a sensible hypothesis, let's see how Ben designs and performs his experiments. Ben works tirelessly to collect data, while ensuring the experiment is as precise and careful as possible. With sufficient data, it's time for analysis. We try to make sense of the results by looking for patterns that the data follow. Analysis highlights the importance of critical thinking as experiment and theory collide. Information can be extrapolated and evolved into an idea we can grasp. In the end, Ben will compare his results with the hypothesis, as he will show whether or not his original speculation was correct. The conclusion is drawn and everything is written up. It's ready to be published. Not so fast. The scientist firstly needs to submit the paper to a journal, which is then distributed to a number of scientists in the field, or peers, for review. You see, the scientific community has to be skeptical. We've learned from the past that accepting bad ideas takes a long time to fix. The peers will check the paper thoroughly, and often will do their own experiments to verify some aspects of the findings. Finally, if the paper meets both peer and editorial standards, then it's ready to be published. It's important to realize that the scientific method is always evolving. A recent development, for example, is the introduction of the post-publication peer review. Now a paper can be put on the internet for experts from all over the world to question and debate, adding an extra layer of robustness. So to sum up, we should trust the scientists because we trust the scientific method. We trust the scientific method because it's based on a series of rigorous checks and balances. In the end, we believe in science because we believe in the power of the human mind.